They are starting the classification of cation when they are systematic investigation or they are systematic analysis. In the last topic, we have already discussed that what is the cation of that particular group and what is the group reagent of that particular group. Now today we will discuss one by one detail. So start from zero group. As we know that in the zero group of cation, there is only one basic radical or cation that is called ammonium. Its formula becomes NH4 plus. Its name is ammonium. Now, when we discuss about the cation or analysis the cation, so first we are taken the salt in a test tube and add sodium hydroxide to the test tube in AOH solution. Then if our salt containing ammonium, then it gives an ammonical smell. For example, if we are taken a salt ammonium carbonate, that is NH4 whole twice CO3, and when we are adding NaOH to that salt, NaOH solution means NaOH dissolved in water. Then after the reaction, the product form is sodium carbonate, that is Na2CO3 plus NH4OH. That NH4OH is further ionized and gives NH3 and H2O. So when we are adding NaOH in the salt, then due to this following reaction, this ammonia gas liberates from the test tube. So liberation of this ammonia gas or formation of this ammonia gas, there is the ammonical gas smell comes out from the test tube. So if ammonical smell comes out from the test tube, then we can say that this salt may be contained zero group, and in the zero group means in this salt, or we have containing in this salt ammonium cation. Sometimes the smell is not comes out in the cold solution. So sometimes we are heating of that solution. So we have taken the salt, adding NaOH solution and heated of this solution. When we are heated of this solution, then ammonia gas comes out to the solution and ammonical smell comes out to the test tube. So if ammonical smell comes out from the test tube, then we can say that this salt contains ammonium cation. Now, this is the preliminary test for the ammonium ion. So, now we are confirming of this ammonium. So, first we are drawing a table, then taken is experiment. Second is what is the result of this experiment, that is called observation. And third is inference. So, we are taking the salt and add NaOH solution to the salt. Then observation if ammonical smell comes out from this test tube. Ammonical smell. Then we can say that here is the zero group. Zero group present and ammonium may be, that is NH4 plus may be. Now after this, we are applying confirmation test for this ammonium radical. For the confirmation test, the first one is we are taking a glass rod which is dipped in the concentrated HCl solution. Glass rod dipped in concentrate HCl and apply on the mouth of the test tube. Now, this side, for example, this is a test tube which contain ammonium salt, and when we are adding NaOH solution to this test tube, then ammonical smell comes out due to the reduction of ammonia. This is the ammonia, and we are taking a glass rod. This one is the glass rod which is already dipped in concentrated HCl solution. This glass rod dipped in HCl solution, concentrated HCl solution. So the observation is white dense fume of NH4Cl. This like example, the test tube, the salt and the ammonia gas. This ammonia gas react with HCl which we are applying on the rod. So when NH3 and HCl react, there is a reaction and form white dense fume of NH4Cl. These fumes. This is the white dense fume of NH4Cl. So we can say that here is the ammonia which confirmed. NH4 plus which confirmed. And in this confirmation test, the chemical reaction is NH3 which is liberating from test tube react with concentrated HCl which is applied in the glass rod. So after the reaction, there is a white dense fume of NH4Cl. There is the white dense fume. So white dense fume confirm the ammonium radical. Now we are applying second confirmation test for the ammonium. That is by the using of Nessler's reagent. Now Nessler's reagent means it's an alkaline solution of potassium tetrahydromercurate. So K2HgI4, that is potassium tetrahydromercurate. It's aqueous solution. It's alkaline solution. This is called Nessler's reagent. With the Nessler's reagent, by the using of Nessler's reagent, we can identify ammonium radical. So in this test, we are adding Nestler's reagent in the test tube. So Nestler's reagent added in the test tube. This Nestler's reagent react with this ammonia which is liberated from the test tube, and Nestler's reagents react with this ammonia, and after the reaction it gives the brown PPT of basic mercury second amido iodide. So it gives the brown PPT of, the observation becomes brown PPT. Brown PPT of basic mercury second, basic mercury second amido iodide, which is also called Miller's base. So when we are adding a Nestler's reagent to the test tube, then after the reaction we find out the brown PPT, that is the Miller's base. So this brown PPT indicated that the salt containing ammonium ion. So here is the ammonium ion is confirmed. NH4 plus is confirmed. The chemical is involved in this is the ammonium radical react with this Nestler's reagent tetraiodmercurate in the basic medium, which is due to the NaOH, and after the reaction it gives the brown PPT of iodide of Miller's base, and the formula of this is HgOHg NH2 ion. It forms the brown precipitate, and 7I minus plus 3H2O. So formation of this brown PPT indicates that the salt contains ammonium ion. Now these two tests, confirmation tests, confirm that our salt containing cation ammonium. Now, if we are taking the salt, and add sodium hydroxide solution to the salt and heating, but there is no ammonical smell, then we can say that in the salt, zero group, that is ammonium radical, is absent. If ammonium radical is absent in our salt, then we are taking another test tube, and in the another test tube again taking small amount of salt and adding dilute HCl to the salt. Observation is white PPT comes out. So if white PPT comes out, then it indicates that this salt contains first group, and as we all know that in first group the radical is lead, that is Pb plus 2, but here is the first group is present. And the first group we are having the radicals, that is lead plus 2. So we are saying that Pb plus 2, comma mercurous Hg2 plus, comma, Ag plus maybe. So if we are taking the salt and adding dilute HCl to the salt, if there is a white PPT, then we can say that the salt contains first group. Now, in the first group, we are having three radicals, that is Pb plus 2, mercurous, and Ag plus. And this white PPT is due to the maybe presence of PbCl2 or AgCl or Hg2Cl2, mercurous chloride. Both PPTs are white in color. So, if we are having the white PPT, then we can say that our salt may be contain lead or Ag plus or mercurous. Now, in the next step, we are finding that what radical present in our salt, that is, this radical contain either Pb plus 2 or either Ag plus or either Hg plus 1, that is mercurous. Now, for confirming of these three radicals separately, we are using a confirmation test. So, for the confirmation test, this white PPT, first confirmation is white PPT dissolved in hot water. White precipitate dissolved in if PPT is dissolved, then this indicates that this salt contains Pb plus 2. Since white PPT of PbCl2 soluble in hot water,
We are having potassium chloride solution. Adding K2CrO4 solution in clear solution. LOPPT of lead chloride comes out. LOPPT of PbCrO4 lead chromate. And since PbCrO4 is insoluble in cold water as well as hot water, so if the LOPPT of lead chloride comes out, then we can say that this all contains Pb plus 2. So if the Pb plus 2 is confirmed again, so in that case what happened? The chemical reaction is that in the hot water we are having a soluble PPT of PbCl2, then we are adding potassium chromate K2CrO4 solution, then here is the lead chromate PbCrO4 is formed, which is insoluble. Since this white PPT is insoluble in cold water but soluble in hot water, it is soluble in hot water, but this lead chromate PbCrO4 insoluble in both cold and hot water. So these two tests confirm that our salt contain first group, and in the first group this will contain cation Pb plus 2. Now we are taking the salt plus dilute HCl and we are having the high PPT and we are saying that our salt contains first group. Now how we can detect that salt contains Pb plus 2, Hg2 plus or Ag plus. So we are dissolving the white PPT in hot water. If PPT is dissolved, then which contains Pb plus 2. But if white PPT, white precipitate is not dissolved, hot water, then this indicates that uh, this salt does not have Pb plus 2. Means if Pb is not dissolved in hot water, then it is confirmed that this salt not having Pb plus 2. Now the problem is that in this salt either may be Ag2 plus, that is mercurous, or Ag plus. So for the confirming of mercurous, Hg2 plus or Ag plus, uh, we are dissolving this PPT in liquor ammonia, that is NH4OH. So first we are saying that if PPT, white PPT is not dissolved, then Pb plus 2. White PPT is not dissolved in hot water, then we are saying that Pb plus 2 is absent. Now further to the confirmation of Ag plus or mercurous, adding liquor ammonia, that is NH4OH solution. If we are adding NH4OH solution after hot water, then if PPT is dissolved, then this indicates that this salt contains Ag plus. PPT is dissolved, this salt contains Ag plus. Since PPT of AgCl is dissolved in liquor ammonia due to the formation of complex, and in that case in that case a soluble complex that is Ag NH3 whole twice plus is formed due to this soluble complex means diamine silver. PPT of AgCl is dissolved. Now the chemical reaction is involved in that case is PPT of AgCl, this react with liquor ammonia that we are adding NH4OH, and after the reaction it gives the soluble complex Ag NH3 whole twice. So due to this formation of complex, the PPT of AgCl is soluble. Now if we are adding dilute HNO3, adding dilute HNO3 in the soluble precipitate, then again white PPT of AgCl comes out, which will be confirmed Ag plus confirmed.
If white PPT is not dissolved with hot water as well as in liquor ammonia, that is NH4OH, then it indicates that the salt not contain Pb plus 2 and not contain Eg plus. So when we are taking a salt and adding to the dilute HCl, white PPT comes out that dissolved in hot water, but if PPT is not dissolved in hot water, then we are adding the NH4OH solution. If PPT is dissolved, then it indicates Eg plus, but when we are adding NH4OH solution, then it it gives the or it turns the white PPT into black due to the formation of here is the black PPT. Since already we are having white PPT, that will be turned in black PPT by the adding of NH4OH solution, and this black PPT is due to the formation of this black PPT is due to the Hg NH2Cl plus Hg. So if we are having a black PPT in the test tube, then we are saying that this salt contains mercurous, that is Hg2 plus. Confirmed. Now further confirmation of the mercurous chloride dissolving this white PPT in aqua regia. So dissolving this black PPT in aqua regia. So dissolve black PPT in aqua regia and adding in the first part SnCl2, then it gives the gray or black precipitate. Gray or black precipitate. So we can say that Hg2 plus mercurous confirmed, and in the second part if we are adding Ki solution, then we are having the red precipitate of HgI2. Which is soluble in excess of Ki due to the formation of K2HgI4, and this indicates the Hg2 plus confirmed. So here is we have completed the first group as well as zero group.